This video is going to cover section 7.1, Basic Concepts of Euclidean Geometry. A lot of this is going to be reviewed, so I'm just going to kind of go to the definitions relatively quickly, okay? So we have a few things here in this box, and this is also found in your book. And it starts off with two of the undefined items, also known as undefined terms in geometry, okay? So we have in Euclidean geometry, we have a point and we have a line. These two things are undefined in the sense that we can't really, they're not made out of anything but themselves. So a point is a point, okay? And the line is a line that goes infinitely forever in both directions. And using these two concepts and something else, which we're going to talk about later, we can construct different items such as angles and rays and just um, different things. Okay, so and it tells us, it just kind of summarizes that here about what they look like. One way to go ahead and identify each of these, for a point, for instance, you would just say point. We would just put the point and then the letter. Okay, so point A, point B. For this one, if this was A, B, you do have to kind of connect 2 points here somewhere because we need to name it. And what you do is you just write your AB and put a little line over it. Okay. The difference between this one and this one, where you just have a line on top, is that this one is a line segment where we're taking a piece of the line, therefore the word segment. Okay, segment means a piece of. So just make sure you understand the difference. So you can even see here, this one right here, this is the line, okay, and this one is the line segments. Okay. We also have something called array. Now, array has a little bit of both. It starts with a point, so there's my point, and then it goes forever in another direction. So it's kind of like what we use to create angles, and we'll talk a little bit more about that. The point at which this starts is called the endpoint. So this would be your endpoint, endpoint A. And just like you see the arrow, to draw this using notation, you would do the arrow going in one direction towards wherever the second point is. So if my B is on the right side towards the arrow, then that's where the arrow is going to go here. Okay, we already talked about the line segment. Pretty much it's just a piece of a line, and this is how you would notate it. Okay, so let's see what else we got. I went ahead and drew a line here, line segment, and I wanted to kind of just take a couple look at some things on this. So would it suffice to say that AB, so that's going to be this piece right here, plus BC is equal to AC? What do you think? Well, yeah, I mean, logically it makes sense. What we're saying here is that this piece, so AB, which would be from A to B, A plus BC, so plus this piece, gives me the entire thing, gives me A, gives me this entire line. And this is called the line segment addition postulate. Okay, we're not going to go too much into the actual definition, but I'm sure you've seen it. But just keep in mind that if that this piece plus this piece is equal to that piece. So for example, if I said that AB is equal to 5, okay, and AC is equal to 7, then what is not AC? Then what would BC be? Okay, so we would take a look at that and say, well, AB, this would be 5. And then this whole thing right here would be 7. So to get the missing piece right here, we would just subtract 7 minus 5, right? You see 7 minus 5 equals, well, it equals 2. But if it was a little bit more complicated and we started throwing x's in there and making you use algebra, you could also use this piece right here. So AB is 5 plus, we don't know what BC is, equals AC 7. So you see how it turns into an algebraic equation at this point, where we could say 5 plus x is equal to 7 minus 5 minus 5. Therefore, x is equal to 2, or BC is equal to 2. Okay, so just kind of keep that in mind. This is kind of an important one that we're probably going to see later on. Okay. All right, so using that same concept that I just told us, where this whole thing is equal. So xz is equal to xy plus yz. We're going to go ahead and try to solve this problem. It says that x, y, and z are all on the line L. So this line right here is line L, okay? Given xy is equal to 9, so this is 9, and yz is twice xy, okay? So they're telling us that yz is equal to 2 times xy, okay? Find the entire thing. I do want to make a note here because if you notice, they didn't really put the lines on top of the xy and the yz. If you don't have a line, okay, let's say you have like how we have it here, this is considered to be the same as this. Okay, so make sure that you know that because it just depends on the book that you're using or the website that you're using. They tend to go back and forth. Anyway, so back to this. So you can tell right away that the answer here is going to be 18. 18 plus 9 is 27. But just to kind of, again, use our math over here, we would say, well, yz is equal to 2 times xy, okay? And xy is just 9. Okay, so therefore yz is equal to 2 times 9, which is 18. And they're asking us to find xz, which would be, remember that xz is equal to these two things combined, xy plus yz, which is just 9 plus 18 equals 27. Okay, that's it. Pretty simple stuff. Okay, let's move on. So we talked a little bit about this earlier when we mentioned the rays. If we have two rays and they have the same endpoint, we can make what's called an angle, okay? And we have some names for this angle. The angle is formed by two rays. Like I said, it has two sides, so there are the two sides. And the endpoint that they meet at, this is called the vertex, okay? Kind of like the corner if you want to think of it that way, okay? When we're given an angle like such, okay, I'm going to scroll down a little bit more. To name this angle, we need to go ahead and put 3 points on it. Now the points can't just be anywhere. We have to have one here on at the vertex for sure. Okay, that one has to be there. Now A and C, as long as you have one on each side, it doesn't matter where it's at. If I wanted to put A down here, I can, as long as it's on one side. That's what we want. We want one letter on, I'm sorry, 1 point on the top side, 1 point on the bottom part, okay? And then there's three different ways to label this. We could label this particular angle, for instance, as angle B, so you label it by the vertex, or you could go in order and do angle ABC, so ABC, you just kind of follow it, or even backwards, where we go CBA. So the thing is, if you cannot say, for instance, angle BAC. Because angle BAC, if you look at that, okay, it would be going from B to A to C, which is a completely different angle, okay? So just be careful with that. I'm going to do a really quick one here on the side just to kind of see if we understand that. So let's say this is, I'm going to name it something else. I'm going to say X, Y, it's a horrible line. I'm going to put Z right here, okay? So we have this little thing in here. By the way, that little thing just, it means angle, okay? So the three ways I could name this angle would be angle Y, because that's my vertex. I could also label it as angle X, Y, Z, so I can go down that way. Or I can go starting from Z, Z, Y, X, Z, Y, X. Can I do angle Z, X, Y? So Z, X, Y? Nope, because that's going to make a different angle over here. Okay, moving on, we're already almost done with this part. An angle can also be named by a variable. So that little like curve thing that you saw in here, you could actually put a letter there and say, well, I'm going to name this angle Z, whatever. This could be called angle Z. Okay, so in this example that we have down here, they went ahead and they kind of cut it in half, not even in half, they just cut it into two pieces. So we have two angles on this one. We have two angles here. We have angle X and we have angle Y. Or you can also think of it as angle X would be the same as angle QRS. Okay. Would you say that this is the same as angle R? Well, in this case, you can't say that because angle R is this entire thing, right? So X is not the entire thing. X is just that little piece right there. So in this case, you cannot do that. This would not be equal to R. This works right here. And this would also be equal to, let's see, we can do angle SRQ because that's still following the pattern. So pretty much if you're not sure, you can always just kind of use your pencil or pen and follow the letters. And if it creates the same, rays that we have connected here to make this angle, then you're good to go. Okay, and the same thing goes with angle Y. Okay, so let's go ahead and look at some more. Like I said, it's a lot of definition stuff first. Okay, we have some more types of angles. Okay, so the angle we saw up there was a basic angle. Here we have three different angles that are used often, and I'm also going to mention a couple more after that. We have the straight angle. Okay, so the straight angle is exactly what it sounds like. It's an angle that's just straight across, and this measure is 180 degrees. Because if you think about it, if you start here, you go all the way around to this one, you've gone halfway around the court. You've gone 180 degrees. Okay, this is known as a straight angle. And again, because we're going in order, you would be starting with B or A. Okay, you can say that this angle is angle BOA. Okay, or angle AOB. Notice that they're the same thing backwards, whichever one you want to choose, okay? And this measure is, of course, 180 degrees. Complementary angles, okay, co-complementary angles are two angles who have the sum of 90. So usually you'll see these kind of like this. It'll be like you'll see a right angle, okay? Remember that little box means right angle. And then you'll have another ray in the middle somewhere, maybe we'll use yellow. You'll have a ray in the middle, something like that. And they'll ask you, okay, what's this one if this one is at 80 or something? So these two would be complementary. This angle X and this angle, whatever it is, would be complementary because they add up to 90. Okay, now if you look here, they went ahead and I put mine together, but they separated theirs. They said, well, I'm going to take angle 60 and angle 30, and those are complementary because 60 plus 30 equals 90. Okay, and that's all it's telling us right here, that angle A and angle B are complementary angles. Supplementary angles are kind of like your straight angle here. They equal to 180. Okay, so it's going to be kind of like the one we have up here, but there's going to be a cut through it where it separates it into two different angles. And this time, instead of equaling it to 90, we're going to equal to 180. So here you can see that 110 plus 70 is equal to 180. Okay. One more thing I want to make note of here, and I didn't copy paste it because I kind of think you already know this, but you want to write this in your notes. Okay. Acute angles. Okay. These are less than 90 degrees. So these two would be acute. So you could say angle A and angle B are examples. Okay. And then we also have something called an obtuse angle, which is the opposite. They are greater than 90 degrees. So in this box that we have here, we could say that C is greater than 90 because 110 is bigger than that. So we can say example angle C. Okay, and you could even say that this one, the straight angle, angle AOB or BOA is also going to be 1. So we can say angle AOB is also obtuse. Okay, All right, lots of definitions. Let's go ahead and start some examples, some actual work here. So we have this first box up here, okay? And it looks like to me that that line L, so remember this line L is a straight angle, and we're trying to find, I'm guessing, the x. So we know that a straight angle has a measure of 180 degrees. So that means that this piece plus this piece plus this piece all have to equal 180 degrees. So what I'm going to do is I'm going to go ahead and just kind of color code them real quick so you can see what I'm adding here. Okay, so I'm going to take 4x and I'm going to add this right here to it. So plus x plus 36 plus the last piece, 3x. And all this should be equal to 180 because this is a straight angle, which means it should add up to 180. Okay, so I'm going to go ahead and add all these up. We have 4x plus 3x. We combine like terms. So that would be 8x. Okay, bring down that 36. And it's a simple algebra problem. Okay, so from here, we subtract 36, subtract 36. So 8x is equal to, what is that going to give us? 144, I believe. Is that right? I believe so. Yeah, 144. And then from there, we just divide by 8. Okay. So in this case, because I don't want to do mental math right now, I'm going to use my calculator real quick. I get 18. So x is equal to 18. Now we could go a step further and say, well, I want to find the actual angles. What would you do to find the actual angles? Well, you would just plug it in. So you would do 4 times 18 here, 18 plus 36, and then 3 times 18 right there. Okay? And that should give you your answer if you wanted the specific angles. But we're just going to move on. That part's not hard to do. If you look at the last two examples we have here, it says find the measure of the supplement of 129. So when you're thinking supplement, you should be thinking 180. Okay. So if I want the supplement of 129, I need to know 129 plus what, so plus some number x, is equal to 180. So to solve this, we just subtract 129, 129, subtract, and that gives me x is equal to 51. Okay, next one, find the complement of a 38-degree angle. So now we're thinking 90 degrees, and it's the same thing. So we know that 38 plus some number x is equal to 90. So all I would do is I would subtract 38, okay, which would give me 52. Hopefully all my math is right. If not, you remember, if you catch a mistake, you let me know. I'll add some points to your homework, okay? All right, so that looks like that's it for this part. We're gonna go ahead and move on. This is, like I said, this is not a difficult unit, but it's just a lot, okay? So now we're gonna look at adjacent angles, okay? So it's kind of like what I showed you with the complementary angles when I did this, and I kind of put them together. But now this is not necessarily a right. They don't form complementary angles necessarily. Okay, it's just two angles back to back where they share one of the rays here. Okay, they're called adjacent angles if they share a common vertex and a common side. So here you can see that they share A, which is their vertex, and they share AC. They share ray AC, okay, which is the side. Okay, and it's kind of like the postulate I mentioned earlier, where you with the line segment where AB plus BC equals AC. So this one is saying this piece plus this piece equals the entire piece. And that's all it is. Okay, so you can see in the example here that measure angle DAC, which is this one, DAC. By the way, this just means measure. Okay, so if you see this, that means the measure of the angle. Okay, so measure of the angle DAC is 45. Measure of the angle CAB, which is the one right next to it. So CAB, so this one, okay, is 55. Measure DAB is equal to both of these. So measure DAB is the entire thing. So that would be this entire thing here. And it's just saying that we need to add them. We need to take this piece plus this piece, and that gives us 100 degrees. Okay, so we're going to use that concept to do this problem right underneath it. We have, let's see, I'm going to go ahead and just color code really quickly. We have that the measure of angle, and let's put a, well, actually they didn't give us an angle, so we don't have to put that. We can put the measure of angle A because they didn't give us a point here, so we're just going to use that little A right there. Okay, so measure of the angle A, we don't know what it is. We know that, let me see. Actually, we're going to need a point for this one because we don't have anything here. So let's call this Y. Okay, so measure angle F, so F-E-Y, F-E-Y, okay, is equal to 68, okay? And I'm gonna assign this. Let's say we know that the measure of angle, let me use a different color. I think I didn't cut off the whole problem, so that's all right. We're just gonna make it up. So the measure of this entire thing now, okay? So measure angle FED. Let's say that's equal to 110, okay? So if we know that this whole thing is 110, okay, so that would look like this. It would be more specific. How would we find letter A? Well, we know that this plus this equals the whole thing, right? So all we have to do is subtract in this part. We would say, well, I know that measure angle FED is equal to measure angle A plus measure angle FEY, which is equal to, well, we don't know what this one is, but we know that this one is 68. And we know that this one is 110. So you would just subtract. Now, obviously, this is a lot easier than we would say. It's going to be 32, so 42. So it looks like measure angle A equals 42 degrees. Do you have to show all this work? Is what I was getting to a few seconds ago. No, you don't have to show all this work, but I do need to see at least this step right here where you subtract, okay? And that's it for that. So let's move on. Like I said, again, these are pretty simple. We have our next type of lines. We have angles formed by intersecting lines. So you can see over here, we have kind of like a cross-looking thing, a T, and it says that if we have four angles formed by the intersection of two lines, and they're perpendicular to each other, then that means that they're right angles. So a right angle is also known as a 90-degree angle. And just in case you forgot what perpendicular means, because I know I didn't really cover that, perpendicular, okay, perpendicular is notated with this, okay? It's when you have two 90-degree angles on each side. Okay, and you have covered this at some point in whether algebra 1 or geometry, okay, maybe even algebra 2. But essentially, if you have this little box, right away the other side is also going to be a box because we know that this whole thing is 180 degrees. So if this is 90, well, this has to be 90, so that way we can add it up and equal it to 180. Okay, 90 plus 90 equals 180. Okay, same thing with the bottom. So now if we look at this piece right here, well, this whole thing is also a straight angle. It also has to equal 180. So therefore, the only thing that's going to give me that is if this is equal to 90 and so forth. Okay, so that's the definition of that. Now we're going to jump to this last part here. We're almost to the end. Okay, we have another figure here where we have two intersecting lines. Now, just because they intersect doesn't mean that they're perpendicular. You can see right away that these are way different these two are different from each other, okay? So these on the bottom are actually called vertical lines. Let me get a different color for that. These are called vertical lines. And, oh, not lines, I'm sorry, angles. What am I thinking? Vertical angles. And vertical angles are formed by two intersecting lines that are not perpendicular. So if they look like this and not like this one, then that means that they're going to be vertical. And the thing about vertical angles is that they form equal angles. So like this angle right here, angle W, is equal to angle Y. And angle X is equal to angle Z. And the reason that is because if you think about it, if we were to think of this as straight lines, so let's say we look at this straight line right here, okay, line P, well, this is a straight angle, right? So that means that X plus W has to equal 180. But if you look at the other line, you look at it this way, well, this is also going to be 180. Do you see the relationship there? So that therefore these two have to be the same. So it kind of follows what happened up here with the perpendicular, except that they look different. You're going to have two pairs that are obtuse, like we have over here. Okay, two that are obtuse, and you're going to have two that are acute to kind of balance each other out. Okay, so with that in mind, let's do an example. We have this figure here, and we know that these two angles are vertical angles and they're equal to each other. So to solve for x, all we have to do is do 7x is equal to 4x plus 36, and we solve. Okay, so I'm going to start by subtracting 4x from both sides, which gives me 3x is equal to 36. We divide both sides by 3. So x looks like it's equal to 12. And if I wanted to find the angle, I could even just plug it in and say, well, 7 times 12 right here, what is that going to give me? It's going to give me 84. And we can check over here. This should also be 84. So let's see, 4 times 12 plus 36. 4 times 12 is 48 plus 36. Let's see, 6 plus 8 is 14. Carry the 1, 84. So we are good to go. Okay. Finally, the last section here. Okay. We have that this symbol right here, it kind of looks like just two vertical lines, means is parallel to. So parallel, and I don't have the definition here, but parallel means that the lines are never going to intersect. That's usually the answer most students give. It also means that the slopes are equal to each other. So if the slopes are equal to each other, that means that they're going to keep going on and on forever at the same rate, and they're never going to cross. Okay, so one really good visual of this is like train tracks. Okay, you have the train tracks like that, right? These two bars, the rails, are never going to cross because if they did this, well, the train would probably not be in good. I don't even know how that would work. You'd have a wheel going this way, this one going that way. So it wouldn't really work out. So that's one way to think about it. Okay. All right. So with that in mind, we're going to go ahead and look at something called properties of a transversal going through parallel lines. So a transversal is this line right here. It's a line that cuts through a pair of parallel lines, okay? And we have some really neat properties that come with this. So I went ahead and wrote them here on the side. We're only going to cover those three in this particular lesson, but we have something called alternate interior angles. So these are angles that are alternate, so they're on the opposite side of the transversal, and they're interior, which means they're on the inside. So that means that if I look at, for instance, angle 3, okay, opposite of so this is the line, right? Opposite of this side is going to be this side. So this would be the pair that goes with that one. So one pair of alternate interior angles would be angle 3 and I don't want to do it that way. Angle 3 and angle 5. And what this does is it shows us that these are going to be congruent, okay? Another pair of alternate interior angles that we have is angle 4. And I'm putting two lines that or two curves, I guess, so you can see the difference, and angle 6 because again, they are inside, but they're on opposite sides of the transversal. So angle 4 and angle 6. And again, these two are equal to each other. So if 6 was equal to, I don't know, 95 degrees, then this would also be equal to 95 degrees. Okay. Alternate exterior angles. So those are kind of like similar to the ones we just saw. Oh, erasing the wrong thing here. Those are similar to these, except that they're on the outside. So now we're looking at angle 2, which is on the outside of the parallel lines, and angle 8. So angle 2 and angle 8 are equal to each other. And then we also have angle 1 on the outside and angle 7. Okay. And finally, corresponding angles. So you can see that we already kind of color coded what we have so far. So corresponding angles are going to be on the same side, but you have one on the inside and one on the outside. So we have some pairs for this one. We can say that 2 corresponds with 6 because you see how they have that same position here. Okay. So we know that angle 2 and angle 6 are corresponding angles. Well, you could say the same for the other side. So we can look at it backwards and say, well, if I were to flip this around and say, well, look at angle 3. Angle 3 matches up with angle 7. So angle 3 and angle 7 are also corresponding angles. And the same thing goes for the other side. So on this side, we have angle 1 and angle 5. Okay, and like so, we have the other one, angle 4 and angle 8. And I'm trying to do just different symbols on there so you can see all the pairs that we have. So angle 4 and angle 8. Okay, so to kind of debrief this, I have one more example and I'm going to wrap it up there. Okay, so let's finish this up. We have this example here, and I believe we're trying to find angle B and angle A. Okay, so to do that, we're going to have to fill out a couple things here because the only one I see a relationship with here is these two, angle B and angle this one. Okay, those are alternate interior angles. And remember that alternate interior angles are equal to each other. So if this is 136, then this is also 136. So measure angle B, okay, is equal to 136 degrees. So there's one part. Now, how do I find A? Take a moment or take a second to think about that. So you should notice that this right here is a straight angle. Yes, it's being cut by this transversal, but this whole thing is equal to 180 degrees, okay? Which means that measure angle A can be found by subtracting 180 minus measure angle B. But measure angle B is just 136. So that's going to give us 44. Let me use a different color for that last number. So let's use this one. So measure angle A would just be 44. Okay. And actually, I know we don't have it, but would you be able to fill everything else out with this? Well, I mean, yeah, because you know that these two are the same. So this is also 44. And then we have vertical angles here. So this is 44. And then we have vertical angles over here. So this is 44. Vertical angles, 136 and 136, which kind of shows you where all of these angle definitions come from. You have a lot of this vertical angle and straight angle stuff going on, and this is why all of this works the way it does. Okay, and I believe that's it, guys. So nice and simple video this time. Go ahead and do your homework, and if you have any questions, let me know.